Now, in surface chemistry, we will see about the preparation of colloids. So, we are aware that colloids are the intermediates between heavier suspensions and lighter solutions. So, lighter solutions and heavier medium suspension, intermediate medium is your colloids. So, colloids can be prepared either by dispersion methods or by condensation methods. Condensation means lighter particles are condensed to get heavier particles, namely in the range of colloidal range, that is called condensation method. Suspended particles can be broken down, that is called dispersion methods. So, methods of preparation of colloids are broadly divided into two types: dispersion methods and condensation methods. So, dispersion methods, heavier particles are broken to colloidal particles. Condensation methods, lighter particles are united to get colloidal. So, dispersion methods in turn can be physical or chemical. Mechanical method. Mechanical method means using ball mill. Mechanical methods. So, here you can use different types of mills, mechanical agents, ball mills, crushers provided with the jaws, which segregate the material into desired particle size. Then the desired particle sized colloids are separated by subjecting them to the action of sieves or sieving. Sieving is separation by passing through some mesh, so that the particles higher than the pore size will be retained on the sieve bed, whereas particles of the colloids will be coming out of the sieve. So, sieving, this is a supplemental method. First, it has to be crushed either by using ball mills or crushers. The crushed particles can be subjected to the action of sieves. That is one method of mechanical method of disintegration to get colloids. So, for example, if you want to, we are having silica particles can be broken down. So, we have observed that normal sand is filtered through the medium. So, sand is filtered. Here, filtering means it is merely a mesh. So, the mesh, the size decides the particle size coming out of the filter bed. So, ball mills or crushers are used, followed by sieving or filtering. That is one mechanical method. Second one, electrical method. Electrical method, it is a named method called Briggs arc method. BREDIGS, Briggs arc. That is, an electric arc is produced between two highly charged electrodes. So, you have a DC direct current, one pole is always kept positive, other pole is always kept negative, very high potential of 3000 to 30,000 volts, or in other words 3 kilovolts to 30 kilovolt. So, high potential is applied, whereby the heavier particles are settled at a particular electrode. You will see what is the principle behind this separation is that the colloidal particles are characterized by charge. So, if they are having some charge, means they will be moving towards oppositely charged electrodes, so that colloidal particles are made to be moved to the oppositely charged electrodes and settled at the bottom. They can be collected. Here, the electric arc is produced. It was developed by Briggs. So, it is called Briggs electric arc method or merely Briggs arc method. Method involves application of high tension DC, HT direct current, high tension direct current of the order of 3 kilovolt to 30 kilovolt potential range, whereby the heavier particles are broken down and settled at the particular electrode. They can be collected. So, these are the physical methods. Now, chemical methods. So, these two are physical method. Chemical method can be in any type, either condensation or dispersion. So, chemical method are of two types, depending upon the type of reaction. Now, we will see the methods of preparation of colloids by chemical means. Important method: hydrolysis, oxidation, double decomposition. So these are the different types of reactions. Double decomposition. Even fourth one, solvent exchange. Solvent exchange. Four important methods by chemical, using the chemical, but first three methods involve actually the chemical reactions, whereas third method does not involve chemical reaction. It allows only the mixing up with some chemicals. For example, what is meant by solvent exchange method? Easy to remember. It is also considered as a physical method, because if you have sulfur colloid, we want colloidal sulfur or sulfur colloid, if we want, means the sulfur is first dissolved in a solvent called carbon disulfide. We know that CO2 is carbon dioxide. Similarly, CS2 is carbon disulfide. So carbon disulfide is a liquid. So it will dissolve sulfur. Sulfur is a solid. It is a heavy particle. So heavy sulfur particles are forcefully dissolved in a solvent, liquid solvent, namely carbon disulfide. Now you have a solution of sulfur in carbon disulfide. Into this, if you add water, we have now a mixture of water and carbon disulfide. Water and carbon disulfide. They are said to be immiscible. Immiscible means they are not mixing together one another. So if you mix these two, you can observe two layers. One is water layer or aqueous layer. Another one is carbon disulfide layer. Now the sulfur present in carbon disulfide will come to water in the form of colloids. So it can be separated as colloids. Water layer can be decanted. Water layer can be decanted or by just tilting. Here there is no reaction between sulfur and carbon disulfide, or sulfur and water, or there is no reaction between water and carbon disulfide. None of the components chemically react. Here only exchange of solvent, that is the solvent CS2 is exchanged with water with the common sulfur in solute. This is called solvent exchange method. Now hydrolysis method. Hydrolysis method means hydrolysis means lysis means decomposition, hydro means water, decomposition by water. Here water is represented as HOH, H2O is represented as HOH. Generally this ferric chloride is dissolved in water. Actually we are not causing hydrolysis, we are dissolving in them in water. If it is dissolved in water, ferric chloride is present in small amount as salt. Water is present in large amount as solvent. So our aim is to dissolve, but it will not dissolve because it will react with the ferric chloride will react with the water, forming ferric hydroxide, and 3 moles of HCl go into solution, hydrochloric acid. This ferric hydroxide is called gelatinous precipitate. Gelatinous precipitate. This gelatinous precipitate is nothing but colloidal ferric hydroxide. Gelatinous means like a gel. Normal fibrous structures or semi-solid structures. They are not strictly solid, neither solid nor liquid. They assume intermediate between solid and liquid. That is the state of colloids. So the salts such as colloids such as ferric chloride can be converted to ferric hydroxide. Yeah, all gelatinous precipitate. Similarly, aluminum chloride, it will be converted to aluminum hydroxide. It is a gelatinous precipitate by the same water. So zinc chloride, zinc hydroxide, any chlorides, but here we have to see metal chlorides, not all metal chlorides. First two types of chlorides, sodium chloride, potassium chloride, these are called alkali metal chlorides. They will be soluble in water, they will not be decomposed by water. It is not possible to get sodium hydroxide colloid by this method. Only by D block elements their salts can be better. So P and D block elements, their compounds can be better observed by this method. So second method is oxidation. So oxidation means here you start with the oxidation concept can be defined in 3 different ways. Addition of oxygen, removal of hydrogen, or removal of electron. So if you consider hydrogen sulfide is converted to sulfur. Hydrogen sulfide contains hydrogen. Now we have removed hydrogen from sulfur. So it is an oxidation process. It is an oxidation process. Oxidation of hydrogen sulfide is a gas, or to a maximum you can have it in liquid form. If it is dissolved in ammonia or water, it will form liquid. But if it is, so hydrogen sulfide, if it is oxidized, oxidation means loss of hydrogen. It loses hydrogen, forms sulfur colloid as a solid. So this downward arrow denotes precipitate, or which separates as a solid, colloidal solid. So some of the compounds, these can be obtained by this oxidation method. We have discussed about Brady's arc method. Brady's arc method will be useful for which type of colloids? For costly colloidal gold, colloidal silver. These can be obtained by Brady's arc method. Even colloidal sulfur can also be obtained. So in these methods, one and the same type of colloid can be prepared by one or more methods. So Brady's arc method can be used for the preparation of colloidal gold or silver or sulfur. This oxidation is not useful for gold or silver, because silver is neither oxidized, gold is oxidized. These are called noble metals. They will not undergo any chemical reaction. So silver compound, we cannot, generally metallic compounds are cheaper, metals are costlier. Here sulfur is a non-metal, so it is affordable. But metallic compound conversion to colloidal metal is a costly affair. It can be converted, but it is a costly affair. That is why it is not recommended for these purposes. So oxidation. Lastly, double decomposition. Double decomposition is a type of method where two solutions, if they are mixed, there is a formation of precipitate. This formation of precipitate is nothing but precipitate means formation of colloids. There it takes, for example, any chloride, barium chloride and HCl, any halide, barium chloride and sulfate, any sulfate, and silver nitrate, any chloride. So any chloride salt can be reacted with silver nitrate. Silver nitrate is soluble in water to get aqueous solution. Chloride is soluble in water to form aqueous solution. Barium chloride is soluble in water to form. So these are soluble in water to form aqueous. But when the solutions, when they are mixed, immediately there is a formation of colloids. Barium sulfate colloid and chloride goes into solution. Here silver halide colloids, AgCl, AgBr. So depending upon if you take chloride or bromide or iodide, it will form AgCl, AgBr or AgI. This is white colored colloid. This one is colored pale yellow. That is AgBr is colored pale yellow. Silver iodide is pure yellow. So there is a shade in color. White colloid, pale yellow colloid and yellow. So silver halides are generally used in photography. So in the photography, we will study about coordination compounds later. So the formation of negatives is made use of only with silver halides. And silver halides are also useful in achieving artificial rain. So even in the application of colloids, later we can study these aspects. Introduction of artificial clouds, rains. So they will splash silver halides into the atmosphere. Silver halide is a reasonably costly chemical that will be splashed into the atmosphere. Due to reactions, it will trigger raining. That is to be noted. So these are some of the important methods of preparation of colloids. So colloids are prepared either by dispersing the heavier coarse particle or by condensing the lighter fine particles. Now we will see some important aspects on the properties of colloids. Now the properties of colloids are classified into three types. However, before going to properties of colloids, let us discuss this, that is purification of colloids. Colloids, when they are extracted by these methods, they are in contact with undesirable materials called impurities. So removal of impurities from the colloidal system is called purification. So important purification methods of colloids are dialysis, electrodialysis and ultrafiltration, ultracentrifugation. Ultrafiltration, centrifugation. 4 important methods. Here dialysis means the colloidal suspension or colloidal solution is made to pass through a semi-permeable membrane. Semi-permeable membrane. Permeable means permeating. That membrane permeates selectively colloidal particles to pass through it, or it retains, so it may selectively allow colloidal particles, or it may selectively allow solute particles, but it will allow only one type of particles. If it allows solute particles, the bed membrane will be rich of colloidal particles. So here the colloidal dispersion is enclosed in a semi-permeable membrane formed in the form of a bag. It is kept for a while. After that, some time the liquid will be oozing out, coming out, and the membrane will be rich of the colloidal particles. It is only purification. So any trace amount of solvent will go out. That is the purification. Purification means removal of trace level of impurities. Not all the major amount of impurities have to be removed, only by other methods. Whereas this is taking, normal dialysis takes place under the influence of gravity. Gravity means Earth's gravity. Slowly it can take place, but it can be forcefully done by the passage of electricity. If electricity is passed through a semi-permeable membrane containing the colloidal dispersion, so colloidal solution is a electrical system. It is having charge. So it will be moving towards the oppositely charged electrodes. Then they can be collected at the respective electrodes. So colloids in themselves are of two types, positive colloids and negative colloids. You will see. So this depending upon the type of colloid, it is collected in the respective electrodes. That is the principle of electrodialysis. These are somewhat methods based on the filtration. Whereas ultrafiltration and centrifugation. Filtration, we know, if it is passed through a filter medium, heavier particles will be retained on the filter bed, lighter particles will be coming out of the filter bed. But the filter bed is made up of very small size mesh. So mesh size, that is called ultra. Ultra means high range filtration. High range means the particle size is very low coming out of this. So the particle size will be reduced by normal filtration will give rise to only salts, which are somewhat heavier particles. Whereas ultrafiltration will lead to the formation of colloids. Here, once again let us compare solution, suspension and colloidal dispersion. Colloids. Here colloids are intermediate between solution and suspension. Normal filtration, you can separate solutes. Whereas ultrafiltration, you can separate colloids. So ultrafiltration separates colloids, normal filtration separates only solutes. No filtration necessary for suspension. Suspended matter can be separated just by allowing to settle at the bottom. It spontaneously settles under the influence of gravity. Last method of purification is ultracentrifugation. Ultracentrifugation. It is based on the type of force. When you consider a circular motion of a particle, two types of forces act on the circular motion of a particle. One type of force acting towards the center, that is called the centripetal force. Whereas other type of force acts away from the center. This is called centrifugal force. Centripetal force and centrifugal force. This centrifugation is predominantly using the centrifugal force. Here the colloidal system is subjected to the whirling action. Whirling. So whirlpool, we tell, washing machine. Whirling means rotating at a faster rate. Pool, storage of water. Whirl, rotating at a faster rate. So here whirling means rotation at a faster rate. When colloidal dispersion is rotated inside a chamber, rotating chamber at a faster rate, the colloidal particles due to centrifugal force will be thrown out, not out of the drum, they thrown towards the surface of the drum or periphery of the drum. So after some rotation, the periphery or surface of the drum will be enriched with colloidal particles. That is meant by ultracentrifugation. This force is based on the centrifugal force. When the colloidal dispersion is subjected to the action of fast rotation in an enclosed drum, during this action, other particles will be at the center of the drum, whereas colloidal particles will be preferentially thrown out because this centrifugal force preferentially acts upon the colloidal particles, so that they will be retained on the surface of the drum. Then from the surface of the drum it can be removed. So that is meant by this is the method for centrifugation. Even in classrooms we precipitate using centrifuge machine. You will have two test tubes. So two test tubes will be there. One test tube will be some pulley like arrangement. Two test tube will be, so it is subjected to the action of rotation, whereby the precipitates will be settled at the bottom. This is the normal method at the lab, but here it is rotated at the drum. In the construction material you might have seen construction materials, the jelly, stone, etc. they are mixed, and slurry is subjected to the action of rotation, but it rotates at a slower speed. That is different. Here it will be allowed to rotate at a faster speed, whereby colloidal particles are settled at the periphery of the drum. So these are the important purification methods for the trace level impurities from a colloidal system. Now, properties of colloids. So properties of colloids are divided into three types: electrical properties, mechanical properties or kinetic properties, optical properties. Electrical properties based on the electrical charge on the colloids. The properties, the reason for the electrical property of a colloidal system is its charge, electrical charge. So colloidal system is charged. Colloids are broadly divided into two types: positive colloids and negative colloids. Positive colloids and, for example, FeOH thrice we have seen. So OH is highly alkaline. Metal is not so acidic. It is a negative colloid. So sulfur may be positive colloid. Gold may be, metals can be positive colloid because they form metallic cations. Metals can directly obtained as positive colloids. So some colloids are positive, some colloids are negative. What is meant by positive colloid and negative colloid? Each colloid is associated with some charge. So positive colloids, major proportion is positively charged species. But you cannot have two positively charged species adjacent, because like charges will repel each other. In between positive charges there will be a negative charge, but proportion of negative charge is less, that's all. Major proportion is higher, positive colloids for positive charge, for positive colloids. So colloids are of two types. So colloids are associated with the electrical charge. Colloidal system consists of two phases we have seen: dispersed phase and dispersion medium. Dispersion medium. So dispersed phase has positive charge, means dispersion medium will have negative charge. Dispersed phase has negative charge, means dispersion medium will have positive charge. So the charges on the dispersed phase and dispersion medium are opposite to one another. As a whole, colloidal system is electrically neutral. Because of the charge of the system, important properties, electrical properties. First one, electrophoresis. Electrophoresis. Second one, electroosmosis. Electrophoresis, electroosmosis. Third one, electrical double layer. Electrical double layer. So formation of double layer. So three important properties of colloids based on the charge on the colloids: electrophoresis, electroosmosis, these two are movement, phenomena of movement, whereas this one is a formation of stationary layer. For example, if you have a colloid, we have seen that colloids have positive charges as well as negative charges. So negative in this fashion. So all the positive charges will form a layer. All the negative charges will form a layer. So there are two layers. This layer is formed due to the electrical charge. So this is called electrical double layer. Electrical double layer. So electrical double layer means formation of layer of one charge, alternative layer of opposite charges. This is a stationary phenomenon. So it is called electrical double layer. Whereas these are movement, phenomena of movement. Means that phoresis means, electrophoresis is the, if we tell the definition of one, other definition you can yourself write. Electrophoresis is defined as the relative movement of dispersed phase. Dispersed phase under the influence of electric field. Whereas this is electrophoresis. So electrophoresis can be defined as the relative movement of dispersed phase under the influence of electric field. Whereas electroosmosis is the similar phenomenon, is defined as the relative movement of dispersion medium. Dispersion medium under the influence of electric field. So only this phrase, the phenomena change. Both are relative movement under the influence of electric field. If dispersed phase moves, that is called electrophoresis. If dispersion medium moves, electroosmosis. Dispersion medium is generally present in larger proportion. It is a liquid. We know about osmosis. Osmosis is a flow of solvent molecules. Here also solvent component is dispersion medium. Flow of particles of dispersion medium, but under the influence of electric field. That is why it is called electroosmosis. So electrophoresis and electroosmosis. Next is the kinetic property or mechanical properties is Brownian movement. Brownian movement. This is also a movement phenomenon, but in the absence of electric field. That is why it is separately discussed. Brownian movement is the phenomenon of random movement of colloidal particles. Random movement of colloidal particles is called Brownian movement. Normal example for Brownian movement, when we keep our windows open, a beam of light you can observe coming into the room. In the beam of light we can see number of particles flowing. So in the beam of light, the number of dust particles will be flowing. It is nothing but dust particles or colloidal particles. Dirt particles are dispersed in air. Dust particles, dirt particles, these are colloidal particles. They are in constant motion. So natural example of Brownian movement is the beam of light through a window from a sunlight. Beam of sunlight through a window, you can observe number of particles rotating. We cannot arrest them and pick them even or touch them even. They will be in constant. We cannot predict their movement. That is why it is called random motion. So Brownian movement is the mechanical property, that is, which states that the property is that the colloidal particles are in constant movement. Constant movement in the absence of even electric field, in the absence of external force. Last important optical property is Tyndall effect. So Tyndall effect is the scattering of light. Scattering of light by colloidal particles. Scattering of light by colloidal particles. For example, if light passes through a system, light can be reflected, refracted, scattered, diffracted, variety of phenomena occur for light. So light, when it passes through a prism, it is refracted. Light, when it passes through a mirror, it is reflected. Whereas light, when it passes through a colloidal system, it is scattered. Scattering means light rays are going elsewhere. We cannot predict their direction in all possible directions. So the best example of scattering of light by the colloidal particles is the questions based on this will be generally asked is only the blue color of sky. So sky appears blue. Why? There is no sky. Sky is not a solid. Sky appears to be a blue blanket. There is no blue blanket. So some region is called horizon. HOR. So distant sky is called horizon. If we aim at touch the horizon, we cannot touch. We can keep on going. We can keep on going. But there is no blue blanket. But to our eyes, there is a blue blanket appears because the atmospheric colloidal particles. They scatter sunlight. So sunlight reaches the earth through the atmosphere. When sunlight reaches the earth through the atmosphere, the particles, colloidal particles present in the atmosphere scatter the sunlight. So this because of this why the scattered sunlight means why should it appear blue? It can appear in any color. Question may ask. That is that of all the rays of light, Vibgyor, violet, indigo, blue, green, yellow, orange, red, blue is the most scattered. Blue is the most scattered light. So it is a composite light. Sunlight is a composite light. Visible and X-rays, every type, UV rays, every type of light is present in sunlight. Among the visible rays which are visible to our naked eye, in the visible rays, the component, blue component is the worst scattered or most scattered. That is why sky appears blue. So the reason for the appearance of blue sky is the Tyndall effect. So based on this, questions will be asked. So these are some of the important properties of colloids. Now we will see some more aspects about colloids in particular.